Assalamu alaikum wa rahmatullahi wa barakatuh. In this lecture, we will talk about concavity. So recall, حكينا بالمحاضرة السابقة if you given a function of x, you can find for this function the critical points, the intervals of increasing and decreasing, and the relative extremum. And you can find the critical points and the interval of increasing and decreasing and the relative extremum من خلال f prime of x. لكن before of that you must find, we say, the domain f x. And we say if a function have a relative extremum, it must be occurs at the critical point. But if the function has a critical point like x to the power 3, x to the power 3 has a critical point 0, 0, but at this point no max and no minimum. For example, for what value of k will f(x) have a local maximum at x equal -2? Since the function have a local maximum at x equal -2, that means -2 is a critical number for a function f(x). Since it is a critical point, that means f prime of -2 equal to 0. Now, f prime of x equal, differentiate this function. 1 minus k is a constant, k over x squared. Then, f prime of -2 equals 0, substitute instead of x minus 2. So we get 1 minus k over 4 equal 0. So 1 equal k over 4, so k equal 4. Now we will start to define what do we mean about the function f(x) concave up or concave down. If you have this function f(x), this is a graph for f(x), obvious this function, the graph of this function concave up. Concave up, that means this function open up. Okay. Now, if we draw a tangent at any point, if you draw a tangent at this point, or if you draw a tangent at this point, لاحظ the slope of the tangent at this point negative. The slope of the tangent at this point increase. Okay, now if this point x1, this point x2, obvious إنه f prime at x2 greater than f prime at x1. Okay. If we define this function g of x from the graph, obvious this function concave down. لاحظ هون إنه tangent below the curve. If you draw a tangent when it is concave down, the tangent above the curve, this is a tangent. So this function we say concave down. Okay. And also this function also concave down, all the tangent up the curve, this tangent. But, okay, if you draw a tangent at this point, now, if we have a function f(x), obvious in f(x) until this point concave down, then it will be concave up. we will define a point. We say this point inflection point. Inflection point, نقطة انعطاف. So the inflection point, a function of x must be continuous at this point, and f of x changes its concavity around this point. Our question, how to find the intervals of concavity? So we say if x is concave up on the interval I if all the tangents to the curve on I are below the graph of f(x). لاحظ from the graph 1 all the tangent lines below the curve f(x), and the function concave down if all the tangents to the curve on I are above the graph of f(x). This function concave down, so all the tangent above the graph. Now, what do we mean about inflection point? A point x0, if x0 is called an inflection point for f(x) if the function is continuous at this point. هذا أول شرط إنه هاي البوينت في domain الفانكشن and the concavity of the graph it changes at that point, and the function it changes its concavity. Maybe the function changes its concavity from down to up, and maybe this function we draw, maybe this function have two inflection point. Okay, so this is up, this is another inflection point down. Now, what do we mean about concave up? In graph 1, obvious إنه f prime للx1 less than f prime للx2, where x1 less than x2. That means f prime للx increasing function. So, if f is differentiable on an open interval, then f is said to be concave up on the open interval if f prime is increasing. فإذا كانت f prime increasing, the function concave up. But the function concave down if f prime للx decreasing. We say about f prime decreasing. So, the function f x we say concave down if f prime decreasing. Now, f prime increasing, when we say f increasing, not, if f(x) not, if f(x) increasing, that means f prime للx positive. Now we say f prime لx increasing. If f prime increasing, that means the function concave up. Since f prime increasing, that means its derivative positive, f w prime للx positive. So to find the intervals of concavity, we must find f w prime of x and study the sign for f w prime of x. إذن لإيجاد فترات التقعر, you find f w prime of x and study the sign. So let f be twice differentiable. Twice differentiable, that means f prime exists, f prime and f w prime on an open interval. Then if f w prime للx positive for every x on the open interval, then f x concave up. If the sign of f w prime positive, so the function concave up. And if the sign of the second derivative negative, then we say that the function concave down. If w prime للx negative, that means f prime decreasing. And if w prime للx positive, that means f prime increasing. Okay. For example, find the intervals on which F is concave up, concave down, and the inflection point. طبعا بإمكانك هاي الإكزامبل إلك to practice أكتر. Find the intervals of increasing, decreasing, and the relative max and the relative minimum. Okay, now we will find when the function concave up, concave down, and inflection point. First of all, you find domain FLX. What is domain FLX? Polynomial, so the domain R, the real number. So f prime of x differentiate equal -4 minus 2x. Now, f double prime lil x equal -2. Obvious, the sign for f double prime always negative for all x belongs to R. كونه انه sign negative, that mean if x concave down on the interval -∞. Is there any inflection point? No. So there is no inflection point. Now, if we define FLX equal x to the power 4/3 minus x to the power 1/3. First of all, what is the domain for this function? The domain R intersection R. Since you have the cubic root x to the power 4 and the cubic root for x, so the domain R. Now, to find the intervals of concavity, you must find f prime and f double prime. F prime of x differentiate equal 4/3 x to the power 4/3 minus 1/3 minus 1/3 x to the power 1/3 minus 1 minus 2/3. From f prime, you can study the intervals of increasing, decreasing, the max will minimum. Now, our aim to find the intervals of concavity. So, find f double prime of x, differentiate. This is equal 4/9 x to the power 1/3 minus 1 minus 2/3 minus 1/3 times minus 2/3, 2/9 x to the power minus 2/3 minus 1 minus 5/3. Before you study the sign for f double prime, you must simplify. Now, we try to simplify. So this equivalent 4/9 x to the power 2/3 plus 2/9 x to the power 5/3. Now بدنا نحاول نوحد المقامات. So this equivalent to. Take the least common multiple between 9x to the power 2/3 and 9x to the power 5/3. 9x to the power. So we multiply this factor by x. So we get 4x plus 2. To study the sign for f double prime of x when this is equal 0. Now, to study the sign, أكيد أي كسر equal 0 if and only if 4x plus 2 equal 0. So x for x equal minus 2, so we get x equal minus 1/2. Now, to study the sign for f double prime of x. To study the sign, the domain R. To study the sign, رح هنا minus 1/2 هنا الزيرو اللي هو صفر المقام. Now, if you choose number greater than 0 like 1 and you substitute in if double prime, choose 1. 4 plus 2, the sign is positive. والمقام also positive, so the sign positive. If you choose number between minus 1/2 and 0, like minus 0.1, substitute, you get the sign negative. If you choose number like minus 1, minus 4 plus 2, if you choose minus 1, minus 4 plus 2, so sign للبسط negative. And the cubic root for minus 1, the cubic root for minus 1 مرفوع to the power odd minus. So you get what is the sign. Okay, we choose minus 1, minus 4, minus 4 plus 2 over 9 minus 1 to the power 1 over 3 to the power 5. Minus 4 plus 2 الإشارة negative over الكيوبيك root للماينس 1 minus 1 to the power 5 minus, so the sign it will be positive. Okay. Now, the function f(x) is concave up, always in the concavity the intervals open. So f(x) concave, لاحظ sign positive, so the concave up on this interval and concave down on the interval minus 1/2 0. So f(x) concave up on the interval minus infinity minus 1/2 open and the interval 0 infinity. And f(x) concave down, f(x) concave down on which interval? On the interval minus 1/2 0. F of x has two inflection points. F of x has two inflection points. So the inflection points are minus 1/2 and f minus 1/2 and 0 f is 0. Now you must substitute the value for f minus 1/2. We substitute in this function. And f is 0, if you substitute, f is 0 is 0. These 2 points are inflection points y. Since f(x) is continuous at this point and the function of x changes its concavity around x equal minus 1/2 and x equal 0. Another example, f(x) equal tan inverse x square minus 1. What is the domain for this function? Remember, the domain for tan inverse x R. So the function inside tan inverse x square minus 1 polynomial, so the domain R. So the domain for this function, the domain R. Now to find the intervals of concavity, we find f prime of x. F prime of x differentiate inside tan inverse. Okay, if we change this function tan x square plus 1, ما في مشكلة. يعني you can do homework, the same function, but instead of minus, you can do, it will be plus. Now, f prime of x, 2x over x squared minus 1. Now, f double prime of x equal الدينومينيتر المقام في مشتقة البسط ناقص 2x times 2x x squared minus 1 times 2 over x squared minus 1 square. So الدينومينيتر المقام في الديريفاتيف للبسط. Okay, now we want to simplify f double prime of x. So we get f double prime of x equal 2 times x squared, 2x squared minus 2 minus 4x squared. So this equivalent over x squared minus 1 تربيع. So this is equal 2x squared minus 4x squared minus 2x squared minus 2 over x squared minus 1 squared. We can write f double prime of x, f double prime of x, take minus 2 as a common factor, you get x squared plus 2 over x squared minus 1 squared. Now, does this is equal to 0? This it will be equal to 0 if x squared plus 2 equals 0, but it is impossible. So it will be never equal to 0. Now, what is the sign for f double prime of x? Obvious in this term always positive. لاحظ إنه البسط always negative. Okay. ولاحظ إنه البسط always negative. So the sign for f double prime, the sign for f double prime always positive. That means f double prime, f double prime, f double prime of x always negative for all x belongs to R. That means f x concave up or down, concave down. Why? Since f double prime always negative on the interval minus infinity and infinity, and there is no inflection point and no inflection point. Okay, another example, if we take the function f of x equal x ln x squared. Before we solve, what is the domain? What is the domain for this function? The domain inside the ln must be positive, so the domain R except 0. X squared always positive, but 0 does not included in the domain. So the domain R intersection R except 0, we get the domain R except 0. Now, find f prime of x, product of two function. الأول x في derivative للن x squared 2x over x squared plus ln x squared times 1. So we can simplify. So f prime x equal 2 plus ln x squared. Now we need to find f double prime of x. F double prime of x, the derivative for 2, 0, plus the derivative for ln x squared, the derivative inside ln اللي هو مشتقة الx تربيع 2x by x squared. So we get 2 over x. Now, to study the sign for f double prime of x, we study the sign on the natural domain of the function. Be careful, 0 does not include it in the domain. Now, if you choose number greater than 0 like 1, so the sign it will be positive. And if we choose a number less than 0 like -1, so the sign negative. So this function concave down and concave up. So we can say f of x concave down on the interval -infinity 0 and f of x concave up on the interval 0 infinity. Now, our question is 0 is inflection point? Obvious no. Why? Okay, 0, the function 0, it is not included in the domain, so there is no inflection point. فلو حكيت إنه 0 هي inflection point خطأ. So there is no inflection point. Okay. As homework, the function of x, the cubic root x squared 3x plus 10 is concave down. Concave down on which interval? Before you solve, what is the domain for this function? The domain R. To find the intervals of concavity, you must find f prime and f double prime. Now, قدرنا نعرف إنه how to find the intervals of increasing, decreasing, concavity, inflection point. كل هاي الأشياء رح تمكننا إنه if we want to sketch a function. So if we want to sketch f of x equal 4x to the power 3 minus 3x to the power 4. لاحظ هذا الفانكشن polynomial. What is the domain for this function? R. This function has no horizontal asymptote, and no vertical asymptote. Now, if you find the limit for f of x as x approaches infinity, this function, the behavior for this function like minus 3x to the power 4. So the limit minus infinity. And the limit for f of x as x approaches minus infinity also minus infinity. Now, first of all, we want to find the intervals of increasing, decreasing, max or minimum. Now, f prime of x, polynomial f prime of x, we differentiate 12x squared minus 12x to the power 3. بإمكانك تقسم على 12 أو لو أخذنا ال 12x squared as a common factor 1 minus x. Now, what is the critical point? When this equals 0, that means إما x equals 0 or x equal 1. So the critical points 0, 0, this point f is 0. We substitute in this function. And 1, and we get this one FL1. FL1 4 minus 3. Now we want to study the sign for f prime. We have 0, 1. If you choose number greater than 1 like 2, بدك تعوض في f prime. So 1 minus 2, the sign negative. If you choose number between 0 and 1/2, 1 minus 1/2 positive. So the sign positive. If you choose number less than 0 like -1, and you substitute -1, this term positive, 1 minus -1, so the sign positive. That means f of x increasing on which interval? On minus infinity up to 1. So this function increasing on this interval, and it will be decreasing from 1 to infinity. There is critical point 1 1 and this point max، وحتى ما حتكون max، حتكون absolute max. وحنشرح إن شاء الله لقدام what do we mean about absolute max and minimum. لاحظ 0 0 is a critical point, but there is no max and no minimum at this point. فليس بالضرورة إنه at each critical point إنه يكون max و minimum. فهيها critical point لكن no max and no minimum. Now find f(w) prime of x. This is f prime. So we differentiate 24x minus 36x squared. We take a common factor. So maybe x equals 0 or 2 minus 3x equals 0. So 2 equal 3x. We get x equal 2 over 3. Now the sign for f(w) prime عندنا 0 و 2 over 3 ولاحظ إنه الدومين R. Now if you choose number greater than 2 over 3 اخترت ال 1. 2 minus 3 the sign negative, so the sign negative, that means the function on this interval concave down. If you choose number between 0 and 2 over 3, substitute the sign, it will be positive. If you choose number like minus 1 منعوض minus الإشارة 12 times minus 1 الإشارة negative, minus 3 times minus 1 is sign positive, so we get the sign negative. That means if x concave down, so we can say if x concave down on which interval? On minus infinity 0 and on the interval 2 over 3 infinity. And the function of x concave up on which interval? On the interval 0 2 over 3. لاحظ this function has two inflection points. What is the inflection points? The inflection points are 0 0 and 2 over 3 and f of 2 over 3. We substitute in the function f2 over 3 عوضت, we get the image 5 over 27. Now to sketch the graph بدنا نشوف البوينت اللي حصلنا عليها. We get 0 0. لاحظ النقطة 0 0. It is a critical point but no max and no minimum. And 0 0 also it is an inflection point. 0 0 is an inflection point. Yes, 0 0 is an inflection point. And we have another inflection point. مين هي؟ اللي هي كانت النقطة 2 over 3 and 5 over 27. So we have this point, 2 over 3 and 5 over 27. This is also an inflection point. And as x approaches minus infinity, لاحظ الجراف approaches minus infinity فأكيد رح تبدأ من تحت. وحصلنا على كمان point اللي هي 1 1. This point max رح تكون أكبر قيمة absolute max. Now we will try to sketch the graph. The graph from minus infinity to 0, لاحظ the graph from minus infinity to 0 increasing and concave down. So this function from minus infinity to 0 increasing and concave down. Now at 0 0 inflection point وسوف يبقى increasing حتى النقطة 1. لكن this function concave down, there is an inflection point, it will become concave up. So this point, inflection point, this function concave up. Now the function increasing until the point 1. لكن عند ال point 2 over 3 we have inflection point, the function concave down and still increasing. Now from 1 decreasing and concave down. لاحظ this function in this interval increasing, decreasing. So from the interval this point 2 over 3. So as x approaches, obvious from the graph, as x approaches minus infinity, the graph approaches minus infinity. As x approaches minus infinity. And as x approaches infinity, the graph approaches minus infinity. This value, the largest one on the interval. So this it will be absolute max. لاحظ الفانكشن اللي بدينا فيه has no vertical and no horizontal. فالbehavior للفانكشن when x become very large infinity, لاحظ بديته from minus infinity. يعني لو جيت انت رسمت like this غلط، لأنه as x approaches minus infinity عم بروح الجراف للinfinity. Okay. If we take the function of x equal ln x squared plus 1, we want to try to sketch this graph. Now, the domain are, what is f prime x equal 2x over x squared plus 1. So when this is equal to 0, when x equals 0, so we get the critical point 0, 0. Why 0, 0? The critical point. لأنه صورة 0 we substitute لن 0 لن 1 0 plus 1. Now the sign for f prime. The sign for f prime x. To study the sign 0, choose number greater than 0, positive, negative. That means f x increasing on which interval? On the interval 0 infinity. And f x decreasing on which interval? On the interval minus infinity. On the interval minus infinity 0. 0 is a critical point. 0 is a critical point and it will be max or minimum. 0 0 رح تكون minimum وحتكون absolute minimum. Now we will try to sketch this graph. This function has a horizontal asymptote. If you try to find limit ln x squared plus 1 as x approaches infinity equal infinity. And if you try to find the limit for ln x squared plus 1 as x approaches minus infinity equal infinity, that means f x has no horizontal. فالbehavior للfunction لما نحاول نرسمه رح يكون الفانكشن as x approaches infinity عم بيروح للinfinity and as x approaches minus infinity عم بيروح للinfinity, has no horizontal asymptote. Now we want to find f double prime of x. This is f prime. f double prime المقام في الديريفيتيف ل 2x اللي هي 2 minus 2x times 2x divided by x squared plus 1 squared. So this is equal, simplify, 2x squared plus 2 minus 4x squared over x squared plus 1. This equivalent to minus 2 x squared plus 2 over x squared plus 1 تربيع. So we differentiate. We simplify 2 times x squared to x squared plus 2. So we get, so to study the sign for f double prime of x, the sign for f double prime of x. لاحظوا study the sign when it will be equal to 0. It will be equal to 0 when minus 2x squared plus 2 equals 0. That means x squared equal 1. So now لاحظ انه المقام دائما موجب فالإشارة حتعتمد على البسط. لو اخترنا الزيرو between minus 1 and 1, so the sign it will be positive. If you choose 2, the sign negative and negative. So if x concave up on the interval minus 1 and 1, and if x concave down on which interval? On minus infinity minus 1 and on the interval 1 infinity. هل يوجد للفانكشن inflection point? Down, up, down. The function is continuous at this point, and around this point the function changes its concavity. So the inflection points are minus 1. وصورة الماينس 1, what is the image for f minus 1 and 1 f 1. Now to get f minus 1 رح نعوض بالفانكشن اللي هو ln x square plus 1. رح أحصل على ln 2. 1 f 1 برضه هاي حتكون ln 2. Now بدي أترك إلك تفكر إنك تحاول تعمل سكتش للجراف، إنه تحاول إنك ترسم هذا الجراف، draw this graph، أو أعمل له سكتش. فكيف بدنا الشكل؟ فنحاول إنه so homework نحاول نرسم هذا الفانكشن بعد ما عرفنا كل الخصائص له increasing with decreasing. So in this lecture you must be able to find the intervals of concavity and the inflection points. إن شاء الله في المحاضرة القادمة we will sketch rational function. لو كان لنا function rational, and we will define what do we mean about absolute max and absolute minimum. So فتراي انك تعمل سكتش لهذا الجراف اللي هو ln x square plus 1.